Okay, this program works, but if you remember, I said that the whole point of this exercise was to look at code structure. Now that we've written some code, let's look at its structure. Is this good code? Well, it works, but is it good? The answer is no. I really don't think this code is good at all, and there's a few reasons for it. There's at least two major ones. The first is that we essentially duplicate all of our variables, and we have hard-coded variables for stars and for dashes. It seems like even though we're doing something for stars and doing something for dashes, we're doing the same thing. We should be able to somehow combine that. And that comes out more clearly in the second problem, which is this whole sequence of code is essentially identical to this, except that we just switched to dashes and stars. In fact, I did it that way on purpose. You saw me copy and paste that when I created it. Duplicated code, even if it's not identical because something is different, in this case dashes and stars, is guaranteed bad coding style. And there's several reasons for that. The biggest one is that if you make a small change to one, it's very easy to not make the equivalent small change to the other. Like in this case, we had a bug in one, right? And so suppose I made the fix to one section of the code, but I didn't make the equivalent fix to the other section of the code. I would have to then go through a whole round of debugging again. And it turns out that that is really, really common problem. So having duplicated code, even if it's not the same, bad, bad, bad. Okay? You're going to lose points. You're going to have to rewrite your code every single time we see you do that. That's just not acceptable. So how do we restructure our code to avoid duplicating our code if it's not even identical? Well, the problem is the data structure we chose is not the right data structure because we have hard-coded variables names for stars and dashes. The first thing we need to do is change our data structure, our representation of the data, our model, to have a more generic form of stars and dashes. We still have to treat them separately because we are counting stars and dashes separately. But instead of hard-coding them, what we can do is, since there are always these pairs, we can use a list. So instead of using, for example, stars and dashes, what if we have a variable called counts? And it's a list where the first element of the list counts the number of stars and the second element of the list counts the dashes. If we were to do that and change all of our code in the same kind of way, then we would be able to rewrite our body of our loops to essentially do the same, execute the code once for the stars and apply it to the first element of each list, and then do the same thing and apply it to the second element. So in other words, we could write this code so that we can do it generically for whatever the current character is, and do that for each character, and each character would apply to a current item in the list. And in fact, you can see where this is going to go. If we do this, even though right now we're hard coding it for stars and dashes, it will now allow us to make this code more generic so it will work for any number of different characters. Alright, so I've done just a little bit more coding here. I set up these three variables, the number of counts, the number of maximum runs, and the current runs. And then what I've done is I've set a constant that says star index, which is 0, which represents that the first element of each list is going to represent the stars, bug, and the dash index is 1, which means the second element of each index is going to represent a dash. All right, so now we've got all of this stuff. We're going to iterate through all the characters in the data, and now I have to do this one other special thing, which is because we have to do work now more generically, we can't have hard coding look at each character, is it a star or an asterisk? We just need to know, is it one or the other? So if we've seen a star, then I'm going to say our current letter index into our data storage is the star index, and the other character is the dash index. So in other words, if we have a star, that means our current character is a star and the other character is dash, and flipped for the other way around. Now let's go through and rewrite the body of this code together. So what we're going to do is, instead of having two whole versions of this, we're going to turn it into one. So forget about if the letter is the star. Right now we know the intention here is the star. So what we want to say, instead of is incrementing stars, what we want to do is increment our current count. So it's counts of what? Which we want to count up the current character, which is letter index, because we've already decided that's our current letter. So if it's a star, then letter index will be 0, and we'll be updating the first element of counts. Okay. If the previous letter was also a star, that means the same thing if we're unchanged. So if the previous letter is the same as the current letter, that's really what this means, right? This code is even clearer because now the semantics are more clearly encapsulated. So if the previous letter is the same as the current letter, then we want to increment our current runs. So it's which runs? It's the runs of our letter index. So we increment our current run length. Now this else belongs to this if statement here, right? So it's no longer the end run of dashes. Instead, it's just ending a run, right? Maybe we're ending a dash run, or maybe we're ending a star run. So if we've ended a run, we want to update our maximum. So here, let's rewrite it. So how are we going to update it? We're going to look at our current run length, which is runs of the current letter. If that is greater than our maxes of the current letter, then we update maxes. Maxes of letter index is equal to runs of letter index. Okay, and now we want to do this same updating we had before, but more appropriately with the new data structure. So we want to update the current runs of letter index and set that to 1, right? So what we're saying here is if we've ended the other character's run, then we want to set the current character's run length to 1. And we want to reset the other one. So we're going to reset the other one by saying runs of other index equals 0. And now, this is the great part, we can delete all of this code. Right? We don't have to do the same thing for dashes because we just did the processing for both characters. And then we still have this prev thing. First of all, let's see if it works. Cross your fingers. Some kind of typo. There always is one max at line 27. Remember, we can just click on this link here. It'll take us right there. That should have been maxes. That's just a typo. Try again. Okay, another one. Oh, right, I didn't update my print statements. Let's go ahead and do that. Okay, this is a little embarrassing. I've actually intended to have one bug in here, but it turns out I had 3. So I'm just going to go through the debugger with you and show you how I find the first bug, and then since I wasn't intending to have 2 others, we'll just fix those. So let's go ahead like we did before and set a breakpoint and see if we can just walk through and figure out what's going on. So I set the breakpoint, I start the debugger, I start stepping through. We've got the previous letter, our current letter is star, you can see over here. It sets the indexes correctly, so the current index is star and the other index is dash. Notice we start off counts as initially 0, 0. We step over this, and now counts as 1 is 0, which means there's 1 star and 0 dashes, which is correct. And now we're going to take an if statement. If the previous letter is the same as the letter index. Now, what is the previous letter? The previous letter is an empty string. And what is the letter index? Well, we can actually just mouse over in the debugger. It's very nice, and it will show us what its value is right there. We could have gone down below and seen it. Letter index is 0. And I realized just by looking at this code in the debugger as I'm checking the values that this doesn't make any sense. The goal here was to check, is the current letter the same as the previous letter? But I had accidentally used auto-completion, and instead of this being letter, I had actually typed in letter index. This is actually what I had meant to type in. If the previous letter is the same as the current letter. Alright, well, let's stop the debugger, and I'm just going to show you what the other 2 bugs are. And If you'd like a little exercise, you can try and find them yourself. But the first one is that in this if statement, when we are ending a run, so for example, we're counting dashes and we just stopped counting stars. In that case, we want to update the maximum run length of stars of the other one. But this is all checking letter index, which is the current character. What we really want to say is if the run length of the other index is greater than the maximum of the other index, then update the maximum of the other index by setting it equal to the value of the current run length of the other index. And then the other thing is when we actually print out the results, I actually printed out the wrong variable name. I want to print out the total number of stars and asterisks, not the current run length. We want the total count and the maximum. Now when we run this, we get exactly the right value, 8 stars with a maximum of 4 stars, which are right here, and a total of 10 stars and a maximum run length of 5 dashes, which is right there. I think that's enough for now on this. As an exercise, if you'd like to do a little bit of extra programming, see if you can genericize this even further so it will work on any sequence of characters, not just 2 different characters. But the main point here is that this code structure is actually much more maintainable because it doesn't have duplicated code.